What's up, YouTube? Mud Duck Sharky here, and today I'm tearing apart a power supply. This power supply is a bit of a problem child. So, I got it from a gentleman. He's a fine gentleman, and he built this power supply, but I don't think he knew what he was getting himself into. So, this shouldn't at all look bad on him. You know, everybody got to learn their mistakes the hard way sometimes, and I think that's the case here. So basically what's going on is there's 4 of these 50 amp power supplies in it. They're the Super China Specials, and you know, they work individually, but you can't just take the things and parallel them and expect them to work. I'm sure there's some supplies out there that you can do that with, and I've seen guys do it. I've got a power supply that's got a few cheap Chinese modules in it, and they're paralleled, and it works, you know. But there's some, you're playing with fire when you go and you buy a power supply and plug it in parallel and expect it to work. It's total crapshoot. And these ones do not like being in parallel. They have all kinds of issues. They don't balance. You know, one of them feeds all the current, and then it clicks off, and then it ends up over currenting the whole fucking thing, and you know, it does weird stuff. So these power supplies are set for a maximum of 13 volts, so I decided to pull one. I decided to completely redo this whole thing. I'm gonna make it kick ass. But these power supplies max out at 13 volts. So if you pop open the lid and replace, focus. Anyway, there's a resistor in there. You replace that resistor with a slightly smaller value, and you've got some more voltage. So these can go up to 16 volts. That's the rating on the output capacitors. So you don't want to go past that. You'll be popping caps. I set most of my stuff for 14 or 15. But we're gonna run this thing through its paces, and we're gonna see why this is cheap Chinese garbage. And you should avoid it if you financially can afford to avoid it. This is, you know, I just have nothing nice to say about it. It's junk. It works sometimes for a while until it doesn't. And while it works, it's not real impressive. So, you know, it's junk, man. If you can afford to avoid it, please do. If you can't afford it, I understand. Everybody's got a budget, you know, and that's why you don't see me running 1.20 gigawatt station over here. You know, I'm just a mud duck because I can't afford to be much more. But if you want a good power supply that's not going to die on you, that's going to do exactly what it says on the label, that's going to regulate the voltage, have low ripple current, and provide everything you could ever want, get a Meanwell. This is a bad mamma jamma right here. So it was pricey. It was very pricey. Focus, you fuck. So this is a 15 volt supply. It'll put out 64 amps if you feed it 220, which I do sometimes. You can adjust it up or down. You can get it up to, I think, like 16.5 or 13.8. You know, anywhere between 13.8 and 16.5. So it's perfect for our radio stuff. Perfect for any automobile sort of accessories. And this particular model is designed to be paralleled. So if you notice, there's a little jack right there. So when you have multiple of these in parallel, it's got a current sharing feature built in. So that little breakdown right there, that's the current sharing plug. So you can parallel these, I think, up to infinity. I believe the data sheet says, if you want to parallel more than 4 of them, please contact Meanwell. So I'm sure you could do it, you know. They're just like, hey, wait a minute, you're playing with the big stuff, give us a call. But yeah, this is a fantastic unit, dude. This is the cream of the crop right here. If you want a power supply, buy a Meanwell, and you know, buy once, cry once. But anyway, we're gonna compare this, a real badass power supply, to that. You know, they kind of look the same, don't they? They kind of do. Well, we're gonna see what happens here. So let me plug this baby in. One of these days I'll get a tripod. All right, so we're rocking at 14.4. So through a series of miscellaneous cables and wires, I have this load tester hooked up. We're gonna crank up the current until it stops, and then we're gonna dial it back a little bit and see what we get out of it. So I'm just using this current meter. I don't know if it's accurate, and I don't really care. That's kind of not the point of this test. The point of the test is you know what? Does this thing have voltage drop? Does it regulate properly? Is it doing exactly what it says on the label? So here we go. Let me connect up this connector here. All right. We got the connector connected. All right, so that's about 40. Well, and that's all she wrote. Okay, so we're getting just below 50. What's our voltage? Oh, 13.3. And that's being measured at the terminals here. So if this meter's worth a damn, we're getting about what it says on the label. It says it's a 50 amp supply, and we're actually pulling more wattage out of it because we've got it up to 14.4 resting, and of course it's a cheap piece of shit, so it sags under load. Assuming this is designed for 12 volts and 50 amps, we're pushing that. We're pushing that amount of wattage. You know, 12 times 50, can't do it in my head, but whatever that is, we're probably right there at 13.3 or whatever it sagged down to. So it works. I'm gonna move on to the next power supply, but maybe I'll pop that open and show you what's inside, and then compare it to the Meanwell, because it's night and day. This looks like a Tinker Toy inside, and the Meanwell looks like a finely tuned machine. But let's plug in the Meanwell and see what we get. All right, so we got the Meanwell hooked up. It's running on 110, by the way. So both of these power supplies are running on 110. Now, if you can read the label in there, this one's rated at 51 amps. It's 120 or 110, whatever you want to call it, and 64 amps at 240. So I've already done this test and I know the results, but I think you're going to be surprised. So this is what you get when you spend the big bucks. So we started at 14. Okay, let me disconnect. So disconnected, no load, 14.4. Crank this up. We're at 60, 70, 80. So this one actually current limits. So right now we're at about 75 amps. Woo! Watch this. As I crank up the load, the voltage sags. So that's pretty impressive. Like I said, I don't know how accurate that meter is, so it's a crapshoot, but the meter's saying 75 amps when it's only rated for 50. So maybe one of these days I'll come back and do this test with an amp meter that I can trust. But for now, this is what I got, and it vastly outperforms the other unit. And it doesn't just shut off when you go past the rated current. It starts to roll back the voltage. Rolls back the voltage. That's what you get when you buy quality stuff. You get something that does more than what it says on the label, and it does it properly without fail. So if you were to plug an amplifier into this and start drawing too much current, it would just say, whoa there, buddy, we're going to roll back the voltage. Instead of clicking off, it's going to roll back the voltage. I wish I had a plug set. I mean, I got the plug set up, but I don't feel like hooking this up to 220 to see what it's going to do. I mean, it's almost meaningless with the janky meter anyway. But yeah, here's your sign. So, like I said, man, if it's in your budget, buy the good equipment, because it rules. It rules the roost, man. Anyway, on a side note, I happen to have this piece of wire in my junk drawer with an Anderson clip on it. It came with some amplifier I picked up a while ago. And I didn't realize that it was copper-clad aluminum until I pulled it out for this test. And I picked up the bundle of this wire, and I was like, wait a minute, something's not right here. This doesn't weigh anything. And through these tests, just running 50 or so amps through it, this is 8-gauge copper-clad aluminum, and it's warm to the touch. Like, I could feel it warming up just in the few seconds that we did these tests. This 8-gauge copper-clad aluminum is the equivalent of like a 12-gauge copper wire. It's a joke, dude. Like, why? Why does anybody buy this garbage? I mean, is it actually cheaper for the current capacity? Maybe. I haven't looked into it. I completely ignore it. It's such a joke, dude. Like, why would you want a gigantic ass wire to do the same job as a small copper wire? Why? Anyway, just don't buy copper-clad aluminum. Buy good power supplies, buy don't buy copper-clad aluminum, buy solid copper wire, and you'll be set on the power situation. You know what I mean? Anyway, so despite the fact that these power supplies are Chinese garbage, I'm probably still going to fix this. I think all I have to do is put some balancing resistors in between each power supply. So that's what I'm going to try first. I'm going to jump in here and I'm going to put some very low value resistors on the positive side of each one of these power supplies so that it balances the current a little bit better. Having these matched very closely in voltage definitely helps with triggering whatever basic protection is in these, because they do have some sort of protection. You pull too much current, they shut off. So, they're not absolute total garbage. They're still pretty bad. We're going to make them rock. And the first thing I'm going to try is the current sharing resistors. Probably 5.1 ohm resistors for each power supply. 10 watts. And if that doesn't work, then I'm going to have to put diodes. I'm going to have to put diodes in series with these outputs, and that's going to drop my voltage even farther. And at that point, I'm probably just going to cut my losses, throw it in the dumpster, and put something else in here. But that's for another video. I got to order those parts and continue from there. But anyway, I hope you enjoyed this video, and I'm Doug Sharkey. I'll be back with another video.